All right, ladies and gentlemen, so what we're going to be dealing with today is the conversion between moles and liters and vice versa, okay? So we are either going to be given a molar quantity to start and asked to get to liters, or given a liter and asked to get to the number of moles. In either case, we need to remember the quantity that we talked about in class today, and that's that 1 mole of any gas at STP will equal 22.4 liters. And the at STP part is very important, okay? So we're going to use this idea throughout the entire thing, and this is actually going to turn into our conversion factor. So you can take a look at example number 1. I have been asked to determine the volume in liters, so I want to end up in liters, occupied by 0.030 moles of gas at STP. So this is going to be my given, and I plug my given in to start, and I'm just going to multiply it by my conversion factor. So that's what this is, my conversion factor. Okay, so let's take a look at number 2 and actually go through it. Alrighty, so we are given the number of liters that we have. So how many moles is what we're searching for of argon are present in 11.2 liters of argon gas at STP. Alright, so we are given liters to start, so I'm going to start with 11.2 liters, dot, line is equal to, and I want to end up in moles. Now I'm going to use my conversion factor. My conversion factor happens to be right here, 1 mole for every 22.4 liters. Okay, so I have liters here, so I want liters to end up on the bottom. So I have 22.4 liters for every 1 mole. And all I'm going to do is divide. 11.2 divided by 22.4 will in fact give me 0.5 moles. Okay, not too crazy. 1-step conversion. All right, let's try another. What is the volume? This time we're finding the volume of 0.05 moles of neon gas at STP. So I'm given 0.05 moles. So I'm going to start with my moles. 0.05 moles dot line is equal to liters. So this time I want to end up in liters, and I want to cancel my moles. So my moles are here. Moles need to end up on the bottom. So I have 1 mole for every 22.4 liters. This time, all I'm going to do is multiply 0.05 moles times 22.4, and you will in fact get 1.12 liters with an S. Alrighty, so I would like you to try number 4 and unpause me when you want to see the answer. Alrighty, so our given is 1.2 moles of water, and we want to know the volume, so we want to know the liters. So all I need to do is plug in my conversion factor, 1 mole for every 22.4 liters, and I'm going to get my number of liters, which actually comes out to 26.88 liters. I'm going to ask you to do the same thing with number 5. Please try it, and then unpause me when you want the answer. Alrighty, so in this case, our given right here is 16.8, so we're going to start with 16.8 liters, and we want to get to moles. So I want to end up with 1 mole for every 22.4 liters. My liters will cancel. I will 16.8 divided by 22.4, giving me 0.75 moles. Alrighty, so if you follow me down, you're going to see that for questions 6 and 7, this process gets just a little bit more complex. Alright, so what I've done is I've given you a reaction. This is actually a decomposition reaction, just to throw a little review in there. And it's balanced already. So I've got a 2, a 2, and a 3 already in my balanced equation. Do note that these should be subscripts, and that I just missed making them subscripts. Alright, now the question says, how many liters of O2 are produced from the decomposition of 0.0250 moles of something else, okay, of the potassium chlorate? Now, I cannot just jump from moles of potassium chlorate to liters of oxygen. It doesn't work. I'm not dealing with the same stuff. So what this ends up being is a two-stepper. Okay, this is going to require 2 steps, okay? Step 1 is going to be a mole to mole conversion. You thought you were done with these. And step 2 is then going to be the mole to liter conversion. All right, so let's go through it. I want to convert KClO3, this guy, to O2. And they are in a 2 to 3 mole ratio. So I'm going to start with my given. That's my 0.0250 moles of KClO3. Dot line. I want to end up in moles of O2 so that I can convert those O2 moles into liters. All right, so I'm going to do my mole ratio. And I'm going to say, okay, I want O2 on top. I want KClO3 to cancel out, so I put it on the bottom. So I'm going to put my KCl coefficient, the 2, on the bottom. That's a 2. And then I'm going to put my 3 coefficient from the O2 on the top. And I'm going to get the number of moles by multiplying and then dividing those numbers. So this number times 3 and divided by 2. And that's going to get me 0.0375 moles of O2. Okay, but that's just step 1. So we've accomplished step 1. We've gone mole to mole. That should be review. The next part is doing our mole to liter conversion. So what you're going to want to do is take this number of moles, so this guy right here, and we're going to do a new step, 0.0375 moles, dot line, and I want to end up in liters of O2. All right, so if that's the case, I'm going to do exactly as I've done all these steps up here, and I'm going to say, okay, I'm in moles. I want to end up in liters. Liters on top, moles on the bottom. 1 mole for every 22.4 liters. And I multiply through for my answer, 0.84 liters of O2. So, slightly more complicated question, but ultimately you're only doing things you already know how to do. Okay, now for number 7, we are going to be doing the exact same thing. So I would like you to give this one a try. You know it's going to be 2 steps. And I want you to unpause me when you'd like to see the answer. Okay, step 1 is here for you. Step 1 says this: we take our given, which is our 14 moles of oxygen, that's our starting number, and we ultimately want to calculate the number of liters of water produced. So over here. So I want to end up in moles of H2O, so I'm going to do a mole to mole conversion. I'm going to start with what I want to end with, my H2 on top. So I take the 2 coefficient from my H2O and I put it on top, and then I take the 1 coefficient from my O2 and I put it right there. Okay, so the O2 cancels, and I'm left with just moles of hydrogen. All right, now try step 2. Alrighty, so here's step 2. We have 29 moles of O2 that we found from our step 1. Okay, and then all we're doing is the moles to liter conversion. We want moles to cancel out, so moles and moles, and we want liters on top, so we do 29 times 22.4 liters, and we will ultimately get an answer of 649.6. Alrighty? Okay, thank you for watching. We'll have plenty of extra practice on this in class tomorrow.